Let's talk about variables. How's it going, guys? It is Jake talking about computer science yet again. This discussion is going to be more focused around the fundamentals of variables, specifically like passing a variable by value and by reference. This kind of got brought up because I was reading a quote, and it was inspiring quotes. It was basically that coding is more thinking than it is typing. As simple as that is, I thought, yes, that is so true. And I guarantee, like, maybe in the beginning when you're learning computer science, learning how to code, it doesn't feel that way. But as you get into the workforce and as you get into these crazy complex problems, you're really just sitting there thinking. And then you call one Python library that does it all for you. And that is, that's how it works. But no, I wanted to just have a general discussion around what variables are, and maybe a better / proper way to think about them. So I have this whiteboard behind me, and let's talk about what are variables, how do we think of them, and how maybe we could better think about them. So usually when we talk about variables, we talk about an object and its name. I think that is, pretty common. I mean, we have this person object right here, and we're going to call it Dave. Person could be whatever, it's some sort of constructor. Let's imagine we're writing in Python real quick, and maybe person has like, a dot name, so there's probably like a name associated, maybe like an address, maybe like an email, whatever the application is. But Dave is equal to that person in memory. So Dave points to that person in memory. And usually, not always, but usually, and this is how I thought about objects for the longest of times, was this meant we had a box called Dave, and inside it was a person. Like so. That's fine. And I want to bring this back to kind of that passing a variable by value or passing a variable by reference, because that's where the benefit of this thought process is going to come into play. So, having a box called Dave to hold person is fine, especially if like I have x is equal to 10. We have a box over here also with x, and inside of it is 10. No big deal. There's no problem with that. But when we're talking about passing by reference, we're essentially saying that we can have multiple different variables point to the same place in memory. And that is an important concept. Let me give a second here. Let's draw out like this. If we're saying that this down here is our memory, so we'll call this our memory down below. Essentially, person is going to get constructed first. Person, when we have Dave is equal to person gets executed, and person comes and fills up, let's say, these two memory locations. However long they are, not a big deal. And Dave then, so after person gets created, Dave then can come and say, oh, I'm going to point to here. All right, that makes sense. And this can kind of work in that box concept. But let's say we have, maybe Dave he's a writer. And those writers, man, they love to have names. Or what is there, like their pen name? Their ghost writer name? I don't know. But let's just say Dave goes by Jared. So we'll have Jared. All right, it's Jarrett, because I can't spell right now, is equal to Dave. And what this actually, means is that it could mean two things. It could mean that one, we either overloaded the equal operator, and this is like, constructing. You could have it probably to like not confuse the two. We could have a person constructor that is overloaded with Dave, so that way we know that Jarrett is a second person. And we'll just use my name. We'll use my name as Jake is equal to Dave. So this would be saying that Jake's location in memory is equal to Dave's location in memory. And that just means that, hey, we have another pointer pointing to the same place, Jake. So does it make sense to say that these variables are merely just boxes that hold a value? I would argue that instead of thinking of it in that way, we could think about it in the terms of a sticky note. As lame as that sounds, a sticky note, that's not cool. But we have a variable. We have these places in memory as we choose a different marker. We'll say down here and here. We have our, and I'm just gonna probably just use, I hope that we're not running out of space. I don't know if that is gonna be the case, but we'll have D and J point to one box, and we'll have our Jarrett dude over here point to another box. So essentially what we're saying is, instead of viewing each one of these as Dave as a box, as Jarrett as a box, let's think of these as objects, the persons as objects, and we can just put a sticky note on each of these. That way, when we have multiple different people or multiple different variables that are pointing to the same object in memory, it makes sense. That object in memory can go by many different names. That doesn't confuse us. Yeah, that's it. Going from box to Dave contains person, Jarrett. And you could say that it's a box within a box with the pointers, but at that point, I think this box concept kind of makes it seem like there's this extra bit of memory that's made to encase the object, when in fact the object just gets made, and for our sanity, we can give it a name, a variable name, whatever. If we ever open up a object in a, what is it called, assembler, if you ever decompile a program, all your variable names are just gone. They do not exist. It is ones and zeros and crazy names. So that is going to kind of explain this. And back when I was talking about this equals operator, I think we're safe to kind of So I kind of just destroyed the board real quick, but there's one concept I also want to talk about and speak on, and that is the difference between this equals operator, this guy, and the is operator. And this is exclusively to Python, but I think in some other languages there's a similar concept. What we're trying to say here is, in the first statement, Jake is Dave. In Python, this is interpreted as, is the ID of Jake equal to the ID of Dave, where the ID function actually returns the place in memory that the variable is. So this would return the memory location of Jake, and this would return the memory location of Dave. And with this, you could, see, hey, are these variables pointing to the same reference? And if they are, sweet, we'll go into that if statement. Whereas if we have an equals operator, we're going to be looking at the value of Jake, so whatever Jake's name is it equal to Dave's name, and all in this person object. And yeah, so and that's why also in Python you might see, if variable name is none, if this object didn't exist in memory, it would return none. And you don't get those null exception errors when you're trying to access a value. You're just seeing the memory location instead of trying to access a value in a struct. So that is going to be kind of just a spin-off on the difference between is and equal, since we're talking about references and values. But yeah, I think this is good for a whiteboard video talking about references. So yeah, real quickly, this was my first whiteboard video. So I'm not sure how it was. It was probably a little cringe at some points, but I hope it was enjoyable. I definitely love talking about, topics in computer science. And if there's anything that you would be interested in learning more about, just comment below. But this was pretty much a video just talking about, the difference between a reference and difference between values of an object, and maybe a better way of thinking about it. Instead of thinking of it in that box construct where we have X is a box that contains 10, we can have 10, the object getting constructed, and then the name just being a sticky note on the object itself. Because at the end of the day, we can have multiple references to the same object. That's the beautiful thing about computers. And I think that's just a better way of thinking about it. Thank you for sticking around. Yeah, till next time. Peace.